In this lecture, we will look at a recap of what we learned in this section of the course. Searching is finding a value in a collection of data. There are several types of searches. In this section, we learned about linear search, binary search, and interpolation search. A linear search is a sequential search over each item, one by one. Each item is checked. If a match is found, the item is returned, and if not, the search continues until the end of the collection. A binary search is a fast search algorithm that uses the divide and conquer strategy. In order to perform this search, the data needs to be sorted. The search starts in the middle, then goes left or right, and repeats, with the data being cut in half each time. We can perform a binary search using iteration or recursion. An interpolation search is like a binary search but better. Values are sorted and uniformly distributed, meaning the probability of each is the same. Interpolation searching uses a probe position and is used if we know the location of the item in advance. Examples would be looking for a word in the dictionary or names in a phone book. Sorting is ordering the data in a collection. There are several types of sorting. In this section, we learned about selection sort, bubble sort, quick sort, merge sort, insertion sort, radix sort, heap sort, and shell sort. A selection sort goes through the collection and finds the smallest element, which it puts at the start of the list. Then it finds the next smallest element and puts it as the second element in the collection. The process repeats until the collection is in order. A bubble sort is one of the simplest sorting algorithms. Each pair of adjacent elements is compared, and the elements are swapped if they are not in order. This type of sorting is not suitable for large sets of data. A quick sort uses a partition, also called a pivot. One large collection is split into two parts. One part holds values smaller than the pivot, the other part holds values larger than the pivot. Any elements less than the pivot come before it, and any elements greater than the pivot come after it. Quicksort is efficient for large datasets. However, quicksort is also unstable because it may sort items that were already sorted. A merge sort is based on divide and conquer. It splits the collection being sorted in half. It breaks it down until it cannot be split anymore. Then it puts it back together and sorts it as it merges them back into one sorted collection. An insertion sort keeps part of the list sorted. It examines if an element is in order or needs to be inserted into the sorted part. A radix sort sorts the collection based on digits, starting from the rightmost digit. A heap sort is one of the best sorting methods. It involves converting an array of data structures into a heap. We create a heap of unsorted data. Then we remove the largest or smallest value. We then reconstruct the heap and repeat. A shell sort is a variation of an insertion sort. It avoids large shifts, making it more efficient, but follows the same basic concepts as the insertion sort.